scientific notation, and why is it used? Think about this question during the lesson. Louisa is researching the approximate distance between Earth and the Sun. Her father told her that the distance is 9 and 296 thousandths times 10 to the 7th power miles. An astronomy book said the Sun is 92,960,000 miles away. Which distance is correct? The distance stated by Louisa's father, or the distance in the book? Louisa's father used scientific notation to express the approximate distance because the distance is so great. Numbers in scientific notation have two factors. The first factor is always a number greater than 1 and less than 10. The second factor is always a power of 10. Why is it important to keep some of the digits from the original number instead of just using a power of 10 to estimate it? You want your estimate to be close enough to make accurate calculations or comparisons. For instance, 9 and 296 thousandths times 10 to the 7th power is more than 9 times 10 to the 7th power. When measurements are rounded, pay attention to the number of significant digits. The trailing zeros in an estimate are not considered significant. The numbers 92,960,009 and 296 thousandths times 10 to the 7th power each have 4 significant digits. Do you see the relationship between the two numbers? How many places do you need to move the decimal point in the second number to make 10 to the 7th power?
Select your answer.
Write the number in standard form in scientific notation. 92,960,000 has 7 digits. The first factor in scientific notation is always a number greater than 1 and less than 10, so you place the decimal point after the first non-zero digit. Count the number of digits after the decimal point to determine the power of 10. Why does the first factor have to be less than 10 in scientific notation? If it were greater than 10, you could have used a greater power of 10 for the second factor. Both of Louisa's numbers for the distance between Earth and the Sun represent the same distance.
The height of Angel Falls, the tallest waterfall in the world, is 3,212 feet. How do you write this number in scientific notation?
So we look at that first digit. It's a 3, so that goes here. And then the remaining digits become 0. Well, no. Sorry. The rest of the digits go in there. And then there are 3 digits behind the decimal, and that's it.
What is the width of a red blood cell written in scientific notation?
This measurement has 3 significant digits. Write the number as the product of 2 factors. Place the decimal after the first non-zero. Count the number of digits before the decimal to determine the power of 10. So we moved it behind the 7, and then you count 1, 2, 3, 4, 5, 6. So it's negative. 6 is the exponent or power, and the width of the red blood cell expressed in scientific notation is 7 300 times 10 to the negative 6 power meter.
A common mechanical pencil lead measures about 5/10,000ths meter in diameter. How can you express this measurement using scientific notation?
So here, first non-zero is that 5 there. So we have 5 times 10, and you count how many numbers in front of the non-zero. 1, 2, 3, 4. So that'll be to the -4 power.
Part A. Kelly used a calculator to multiply large numbers. How can she write the number on her calculator screen in standard form?
Okay, so we have here 3 and 5/10 with the exponent of 15. So you write 3 and 5/10 times 10 to the 15th power. That means there's 15 places after. So it's positive, so that's why the numbers are going to the right.
Part B. How can Charlie write the number on the calculator screen in standard form?
So once again, you have 8, exponent of -9. So that -9 is there. So the 8, and then you must have 9 numbers in front of that number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's it.
Write the numbers in standard form.
So let's take a look. We have 18. So 9, 2, 2, 5. And so it has to be 18. So I'm going to use zeros. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. I think that's enough. Let's see. Let's count, make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, it should be 18, not including the 9. So let me erase the commas and add another 0. So now let me just choose a different color. My comma should be here, 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 and here. So that will be the standard form for part A. And then we have part B. 6 and 3/10 times 10 to the -8 power. I'm going to delete this so I can write that one. Okay. So now I have 6, 3, and 1, 2, 3, 4, 5, 6, 7, 8. Oh, I did that wrong. When you move fast, you always make mistakes. 6, 3, and because it's negative, it should go in, the zeros are in front. 1, 2, 3, 4, 5, 6, 7, 8. And let's see. Make sure I have the right numbers. So 1, 2, 3, 4, 5, 6, 7, 8. And my decimal should go here. And that's supposed to be a decimal. There we go. And my decimal is there. And that's it.